Okay, in this video we're going to pick up where we left off from the first video, but this time we're going to graph these quadratic functions or parabolas that are in vertex form. So let's just start with the steps. If you'll take these steps and tape them down into your notes, and there's some differences. I kind of altered the step 3 a little bit, and I'll explain that here in a minute. It really doesn't matter if you leave it as they are or if you change it to what I have. It's just a matter of picking your points wisely. So let's just take a look at an example. So if we follow these steps, we want to identify the vertex and plot it on the graph. When it's in vertex form, you can just take a look at it and see that the vertex is going to be at -2, 4. And you will plot that point. The next step, you're going to draw this axis of symmetry through that vertex. So just draw a straight line through that vertex. That's your axis of symmetry. Don't make it too dark. It's really an imaginary line, not really supposed to be a part of the graph. And then next, this is where you choose a couple, and it says 2, but you can do more than that. You shouldn't do any less, but let's take a look at what that looks like. So when I create a table of values, I'm just going to stick the vertex right there in the middle. And I'm going to choose a number a little bit higher and a little bit lower by different increments. Notice that between -2 and -3, it's an increment of 1. And between these two, it's an increment of 2. And I'll show you why we do that here in a second. Next, it's just plug and chug. I call the table of values Old Faithful because you can always go back to them whenever you get stuck. They do take longer, but they are always pretty reliable. So basically, you're going to start with the template, and you're going to remove x, and you're going to plug in the number 3. As you can see, -3 was substituted in for x. And then order of operations, just follow those order of operations. You get -1. Then you're going to square that. It's going to become a +1. Then you're going to multiply by 2 and add 4, and you're going to get 6. And in like manner, we're going to replace the x value this time with 0 and evaluate it, and we're going to get 12. Okay, the last step, or excuse me, step 4, we're going to plot these points and the reflection points. So the reason why I chose different increments was so that I could get different points with different reflection points. So let's start with -3, 6. Now what I mean by reflection point is that there is a mirror image of this point on the other side, and all you have to do is count the steps from the axis of symmetry. So that second point is going to be right there. So if I had chosen -1 here, which was 1 increment to the right, then I would have wound up with a reflection point. By choosing numbers with different increments, you'll get more points. So with 0, 12, there's 0, 12 right here, and its reflection point on the other side of that line is the reflection point. And now you can sketch the graph. And that's how you do it. It's done. We're going to take a look at a few more. Again, you want to identify the vertex, plot it, draw the axis of symmetry, create a table of values, put that vertex right there in the middle. I went 3 units away from 4 from the left to the left, and 2 units away from 4 to 6, and this is where you plug in, take out x, put in 1. 1 minus 4 is -3. Don't be afraid of fractions here. Half of 9. Half of 9 is 4.5, plus 1 is 5.5. Okay, and then we're going to do the same thing with the number 6. 6 minus 4 is 2. 2 squared is 4. Half of 4 is 2. Plus 1 is 3. Alright, so now we're going to plot that first point. Notice the way this graph paper is done. It's very easy to do. And then we can't really do the reflection point because there's not enough graph paper. You can kind of improvise there if you want to. Next, our second point was 6, 3. This one we do have a reflection point. It's the same number of steps away from the axis of symmetry, so it's 1, 2, 3, 4. So if you count over 4, there you go. And now you have an outline of the parabola. Do the best you can. Just don't make it a V. Some people make a very sharp edge right there at that vertex. Try to round it out. And that's done. All right, let's take a look at another one. Identify the vertex. Again, we talked about that in the last lesson. And the axis of symmetry and table of values, a little to the left and a little to the right. Notice that this is 1 unit away from -3 and this is 2 units away from -3. Start with your template, remove x and start with -4. Order of operations, you get a -1. That -1 squared is a +1 times that -2 is a -2. -4 is -6. Okay. And then we're going to remove all the -4s and put in -1. And we get -12. Plot those points. That's -4, -6. And now we want to go with a reflection point. Notice that this graph is not going up, it's going down. And again, that goes along with what we learned in this later, or in the first lesson, and actually Unit 1, that when we have a negative here, it's a reflection graph. Draw a rounded curve right here. Don't make this too sharp. We don't want it to look like an absolute value graph. Okay, let's go with one more. Identify the vertex, the axis of symmetry, table of values, chose the number -5. Again, order of operations. Be real careful right here. That negative is still looming out there outside those parentheses. When you square this -1, it becomes a +1. And then you will negate it and subtract 1, so you get -2. Okay, remove again, plug in a -2 in place of x. Order of operations. Take the square, negate it, you get -5. Okay, plot the first point and its reflection point, the second point and its reflection point, and you're done. Okay, so that concludes this lesson on how to graph parabolas, and we'll see you in class.